This is what solar-powered planes of the future could look like. These aircraft could utilize solar energy as their primary power source. This innovative technology has the potential to revolutionize the aviation industry by offering a sustainable and environmentally friendly alternative to conventional fuel-powered planes. The concept of a solar-powered plane is based on harnessing the sun's energy through an extensive array of photovoltaic cells, which convert sunlight into electricity. These cells are typically integrated into the wings and other surfaces of the aircraft, maximizing the area available for energy capture. The electricity generated is then used to power the plane's motors, propellers, and onboard systems. This innovative approach to energy generation significantly reduces the aircraft's environmental impact and reliance on fossil fuels. One of the key advantages of solar-powered planes will be their ability to fly at high altitudes for extended periods. By operating in the stratosphere, where air resistance is minimal, these planes could achieve greater efficiency and range. The abundance of sunlight at high altitudes will ensure a continuous supply of energy, enabling them to stay airborne for days, weeks, or even months. This capability opens up a wide range of potential applications, including surveillance, communications, and scientific research. The design of a solar-powered plane is crucial to its performance and efficiency. To maximize energy capture, the wings will be large and covered with lightweight, high-efficiency solar cells. The aircraft's structure must be designed to be as light as possible, utilizing advanced materials such as carbon fiber composites. This lightweight construction reduces the energy required for flight, allowing the plane to operate with minimal power consumption. The exterior of solar-powered planes could be covered with an intricate pattern of hexagonal shapes that could house an array of high-efficiency solar cells. Interspersed among these hexagons are larger circular structures with complex internal geometries, which may function as advanced solar collectors, incorporating concentrator technologies, or house sophisticated sensors and communication equipment. Every curve and surface of these aircraft would be meticulously engineered to reduce drag and enhance lift, with features such as upturned winglets at the wingtips, improving efficiency by reducing wingtip vortices. The propulsion system is seamlessly integrated into the wing structure, likely utilizing electric motors powered by the onboard solar array and energy storage systems. These planes will be designed for high-altitude, long-endurance missions, capable of soaring above cloud cover in the stratosphere. This positioning allows them to remain above most weather systems and in constant sunlight, maximizing their solar energy collection potential. The design could also incorporate transparent or semi-transparent sections, providing pilots and passengers with an exceptional view of their surroundings. However, given their long endurance capabilities, many of these aircraft could also be engineered for autonomous operation. The unique honeycomb structure of the aircraft will serve a dual purpose, reinforcing the structural integrity of the design while simultaneously housing the solar panels. The propulsion system is expected to be a hybrid configuration, combining electric motors with conventional jet engines. This approach promises enhanced fuel efficiency and reduced emissions, aligning with the industry's growing emphasis on environmental sustainability. The integration of electric motors offers the potential for quieter and smoother operations, minimizing noise pollution and enhancing passenger comfort. Advanced control systems and artificial intelligence algorithms could optimize power distribution between different propulsion sources, further improving performance and fuel efficiency. The aircraft's interior represents a paradigm shift in cabin design, prioritizing passenger well-being and comfort. Expansive windows flood the cabin with natural light, creating a spacious and inviting atmosphere. Ergonomic seating, advanced air filtration systems, and personalized climate control contribute to a relaxing and enjoyable travel experience. Smart cabin technologies, such as interactive displays and virtual reality entertainment systems, could further enhance passenger engagement and satisfaction. The future of solar-powered planes is promising, As technology continues to advance, we can expect to see further improvements in the design, efficiency, and capabilities of these aircraft. While challenges such as energy storage and weather dependency remain, solar-powered planes have the potential to revolutionize the aviation industry. With extensive research and development, these aircraft could become a common sight in our skies in the not very distant future.